Hello, my name is Mark Horchler, and I'm here from Elemental Technologies, and here at the European Communications Seminar here in London to talk about how telcos and mobile operators can use software-defined video to launch a successful OTT service. I'm going to cover a little bit more of the technical aspects of launching a successful OTT service. We talked a lot about the kind of the business and strategy and marketing aspects. I wanted to focus a little bit on what are some of the technology success factors for launching an OTT service. First of all is efficient usage of bandwidth, how to compress and video to the point where you can make the most efficient use of your available bandwidth. How to support, you need to be able to support multiple devices. Monetization, Mark talked a little bit about earlier about how a lot of the telcos are looking to launch OTT services as a way to retain subscribers, but there are other ways we can also generate return on investment. And content protection, this is for how we can protect valuable content through an OTT service. And finally, how can an OTT service rapidly respond to changing market trends? So efficient bandwidth usage, if we go back in history a little bit, we'll see that the initial digital video started really with MPEG-2 and back in 1994. This is the standard that was used for the DVD format and is still being used in North America mostly for digital cable and satellite. Since then, we had AVC, or also known as H.264, or also known as MPEG-4, which was offered 50% more efficient video compression over MPEG-2. H.264 was what is behind most of the HD broadcasts, especially here in Europe, and so we'll see that there was a significant improvement. But what happened was back in when H.264 the standard was finalized and it was introduced, it took a while before H.264 was used by broadcasters and operators. For the mere fact that it took a while for the H.264 video processing and transcoding equipment to come on the market, because it used a lot more processing power than MPEG-2, and so you need to design special chips, ASICs, or use FPGAs or DSPs, and so it took there's always a lag time from the introduction of a new video compression standard and the time it takes to get the equipment up and running. Since then, we have HEVC, which is the most recent standard for video compression. HEVC is 50% more efficient than H.264. So, however, it does require a lot of more processing power, up to 10 times more processing power on the video processing side than H.264. On the other hand, at the same time, we have, again, looking back, MPEG-2, H.264, HEVC, every 8 or 10 years, there's been a new standard that's been introduced for codecs. Each one requires more and more processing power. They're more sophisticated. They offer more features. They support a number of new types of video formats. For example, HEVC is what's behind most of the 4K broadcasts. And yet Moore's law, the famous Moore's law, continues, and it's gotten to a point where off-the-shelf components, off-the-shelf CPUs and GPUs, graphic processing units that we use in our home computing devices have become so powerful that HEVC processing can now be done through software. And this means that it's a lot more flexible and a quicker launch to market. So a little bit. Okay. So one of the challenges, as most of you know in this room, is The delivering video today is very different than it was years ago, but we no longer have one device to look at. We're not just broadcasting to a TV set, but we're looking for hundreds and literally thousands of different types of devices we need to address. Tablets, iPhones, computers, set-top boxes, USB sticks, all sorts of different devices. And so this is a real challenge. And how do you keep up with all these different devices? The answer again is through a software-defined video, using software to be able to continually keep up with all the different devices that are coming onto the market. So that means, for example, in the multi-screen OTT world, there are currently several different flavors of what we call ABR, adaptive bitrate streaming. Again, adaptive bitrate streaming is what allows you to adapt the video quality depending on the bandwidth that's available. So some of the standards, well, there's Adobe Flash HDS is one for devices equipped with Flash players. Microsoft Smooth Streaming. If you're watching video on an Xbox, you're going over the internet, you're probably using Microsoft Smooth Streaming. HLS, which is HTTP live streaming, which is the standard. It's used primarily by Apple, so all the Apple devices, iOS devices, or typically would use HLS. A lot of set-top boxes as well. And so there's a number of different standards for video streaming on the market, and the industry has come together and tried to introduce a new standard to try to unify that, and that's called MPEG-. So MPEG- is a new industry-wide online OTT streaming standard that has a number of advantages, but nevertheless you're still dealing with at least 4 different online OTT video streaming formats. So I won't go too much into details. I know this looks very technical, but to just simplify things. So what happens typically is you would need to generate 5 different profiles or 5 different levels of picture quality to be able to support mobile devices over the top. A very low one for very bad or very poor bandwidth situations, and the optimal one, which in this scenario would be HD 1080p. So what you would do in some cases is that you would need not only that, but you would need to have 5 different streams for one single source of video in the 4 different flavors of video, OTT video streaming. So that means that 20 streams in total for a single video source, which is not the most efficient way of doing things. So with software-defined video solution, such as our Elemental Delta Origin server, you can package the video content for the device on the fly, either at the origin server, or at the edge, so really close to the actual user. So that means you only need 5 streams for one stream for each profile, and then you can repackage the video content just in time, depending on what type of device is accessing that. So it's a much more efficient way of doing that. And again, with a software solution, you can adapt and quickly cater to all the different types of devices that are coming onto the market. So another important aspect for operators in launching an OTT service is monetization. So as we discussed earlier, a lot of telcos are looking at launching an OTT service for the purpose of maintaining or growing their subscriber base. Others are also looking to offer pay TV services and generate revenues through that. And another way of generating revenues is through advertising. So the telcos have an advantage in the market in that they have they know a lot about their actual viewers. So if you could target advertising to those viewers based on their gender, based on their likes, based on their location, you can introduce a whole new type of advertising that that only that only telcos can really provide in this, because it's not a mass advertising scenario, but you're looking at targeting advertising for each specific device that your subscribers are using. So ad insertion is an important thing to think about when launching an OTT service. So being able to, someone's watching whether a live stream or a VOD stream, and then having that ad specifically targeted to them is a very powerful thing, and we believe it's going to be a key source of revenue generation for OTT services. Now, for pay TV, especially for pay TV services, for the expensive content, whether it's live sports or Hollywood films, being able to encrypt and protect your content is very important. But again, one of the challenges that telcos and mobile operators face is that there are so many different devices they're addressing to. They're not just sending it to a set-top box. They're also sending it to iPads and Android phones and all sorts of different devices, each one with different types of DRM standards and different types of content protection. So by being able to support multiple DRM systems through a single software-defined video infrastructure, you'd be able to address literally dozens of different DRM solutions by packaging, by encrypting, and by applying the key server, the keys to the video content on the fly, just in time. Again, one development there is in the MPEG dash, which I was talking about earlier, is the introduction of SANC, a common encryption format. So this means that different DRM systems can share the same encrypted video file using AES-128. So there's a lot of things going on there. But concept protection, being able to apply the different DRMs to different players and different devices in real time is critical in being able to launch a successful OTT service. So again, just round up efficient bandwidth usage. We're looking at HEVC as a way to greatly improve the bandwidth efficiency of your network, as well as offering more HD and launching 4K as well. Being able to support multiple devices through just-in-time packaging is critical. Targeted advertising is going to be increasing way for telcos to generate additional revenues through their OTT video services. Content protection, being able to protect and be able to encrypt content and being able to address all the different DRM systems and players and devices that are out there in the market. And most of all, of course, is to be able to rapidly respond to market trends. And this is where we see software is the way forward. Software-defined video allows you to rapidly respond to the market. You don't have to take out an old piece of hardware in your infrastructure and replace it with something else. You can just upgrade your software, tweaking a few lines of code, integrate it with some other software. Through software, you have a lot more flexibility, and you can be able to respond to different market trends. I know Paolo is very good at predicting the future, but no one is able to tell you exactly what kind of new technology is going to come up in the next couple of years. So it's important that you have a system that's flexible enough that you can quickly adapt and lead the future trends there. So software-defined video networking also allows you to run your infrastructure on the ground, on premise, through using off-the-shelf hardware devices in a rack mount or in a blade server type environment. You can also virtualize all your video processing delivery in a virtualized environment, or you can also run it in the cloud. And we're seeing an increase number of operators and telcos looking to run their OTT services through the cloud, whether it's entirely through the cloud or it's a mix of on-premise and the cloud. That's all possible thanks to the flexibility of software. So thank you very much. If you have any questions, I'll be around to answer.